Hi friends, welcome back. Let's continue our journey into the topic reinforcement learning for robotics. So for the reinforcement learning, we have two types of learnings as we discussed in our previous session. One is exploration and the other one is exploitation. So let's see them in detail one by one. So let's begin in this session to see what exploration is all about. So when we begin our game, the environment is totally unknown to the agent, and exploration is a activity that provides better strategies. So when we know nothing about environment, we can't make any strategy, which action to take, and all that. So the only option left is start somewhere. So start somewhere, maybe start with some random action, and once we take some random action, we get a reaction, maybe in the form of a reward or a punishment. So remember that, and then continue exploring the new environment, continue working on the unknown environment with some random actions and keep increasing the knowledge bank as for such an environment or such a state of the environment. If the action taken is such and such, then the reaction is either a reward or a punishment or so and so. So this way we keep building the knowledge bank, and through exploration we build an accurate model of the environment. So that is one option. Or if we are working on a model free system, then exploration is used for refining the Q values. Yeah, we have two types of models. One, two types of reinforcement learning. One is model based and the other one is model free. What these two are, we see in our coming sessions. But as of now, if we are working on a model based reinforcement learning, then exploration will build an accurate model of the environment. So here we explore the environment through taking the random actions and try to know what the environment is, and we create a digital model equivalent to the environment. If we are working on a model free system, then we do have something called a Q value, and this Q value gets refined as we explore newer and newer possibilities. So there are various types of exploration process. So let's look at one by one. So there is the simplest thing possible is a random exploration. Here, the action selected at any given state is randomly selected, and because of random selection, we don't have to think much. So just take up randomly any action in the given action set and act upon. So looks efficient in the early stage, but as we keep moving, then it becomes more and more inefficient. So what we can make is try to use algorithm like epsilon greedy, where the exploration is done randomly. The other form of exploration is directed exploration, wherein the agent systematically explores. Instead of randomly exploring, it systematically explores. So this exploration is based on some measures of uncertainty. We just don't take up anything randomly. We make use of some measures of uncertainty like variance, mean, and then through that we find a action to be taken for a given state. And in this type of exploration, we encourage visiting less visited states. So when we are taking any action, we just try to see that the next state is the one which is less often visited by the system. If it is quite often visited, we try to avoid that. So that is one of the ways so that we can explore unexplored areas of the environment. So the one which is less known is more preferred than one which is well known. So that's a process of exploration, of course. So directed exploration is to ensure that the less explored regions of the environment is given the priority. The next step is about decaying epsilon in epsilon greedy. So epsilon greedy is a process where epsilon is a ratio of exploration to exploitation. That means how much part of the time the system is going to explore and how much part of the time the system is going to exploit. This ratio is the epsilon. So in the epsilon greedy, we first decide that for how much of the duration we are going to explore, and after that we switch from exploration to exploitation, and the remaining time we work on the exploitation. Say, for example, if the epsilon value is 0.1, it means that for 10% of the time, the system will explore or the agent will explore the environment, and rest of the 90% of the time, the knowledge gathered through exploration is used and policy is built according to the knowledge available and will follow that policy for 90% of the time. Only first 10% of the time there is random exploration. So that's what epsilon means. But here, in the previous case, where we were talking about random exploration, we had an example of epsilon greedy, where epsilon is supposed to be fixed. Now we can make epsilon vary because when we begin our journey, nothing is known. Therefore, we want to stress more on exploration rather than exploitation. Therefore, we begin with the highest value of epsilon, that may be 1. That means we, in a given period, the whole period is dedicated for exploration. And then as time passes, the value of epsilon is gradually reduced to a very small value. That means in the beginning, we know nothing about the environment. Therefore, we would prefer to exploit the environment, explore the environment, I'm sorry. And then As we explore, we gather the knowledge about the environment. Therefore, we are now able to exploit the environment. Therefore, we keep reducing the value of epsilon. So, with time, the exploration time is reduced and exploitation time is increased. So, gradually, so this allows early learning followed by a stable policy convergence. So, because in the beginning, epsilon value is high, therefore, a lot of exploration is possible. So, we try on almost all possible action state combinations randomly, and then we have a good knowledge bank. And then, as we move further, we try to exploit this available knowledge rather than exploring. So, with time passes, we prefer to exploit more and more rather than exploring. So, in the beginning, we have a good learning possibility because of exploration, but as time passes, we have sufficient knowledge about the system. Therefore, we can create a policy that is a stable policy can be created, or through this process, as we keep reducing the epsilon value, we are moving towards creating a stable policy. That means there is better convergence of the policy. Then we have Boltzmann exploration. So these actions chosen are probabilistically and Q values. Then we have something called upper confidence bound algorithm. So here we balance the reward and uncertainty, and this method promotes actions that are promising, that means that high Q values, and also tries to use the ones which are less tried. Then we have something called intrinsic motivation or curiosity, rewarded for novelty. So this is one which encourages exploration in sparse reward environments. Then we have Thomson sampling type of exploration which makes use of Bayesian method. The samples from the distribution over the Q values are used for sampling, and from the samples, the best action is selected, and this naturally balances the exploration and exploitation. So there are some challenges we have with exploration. So when the rewards are sparse, then it is hard to find signals that are useful for guiding learning process. Large and continuous state space. So if we are working on a continuous state space, then a lot of values are there in the state space. The size of the state space is so huge that we do require a smarter exploration technique rather than random version. Then another problem is with delayed rewards. Every action may not get immediate reward. So because of this delayed rewards, some of the good actions may not be immediately visible. So these are some of the challenges we do have in exploration techniques. So that's about the exploration where we begin our journey with nothing known about the environment, and we explore the environment through taking the actions with no knowledge about the environment, and that's exploration. As we explore, we gather information about the knowledge, information about the environment, and then we can use this information for exploiting the environment and finding the best solutions in the future. So that is what exploitation is all about, which we will see in our next session. Keep watching. Thank you.